Oh joy, the next slide is an easy one, thank goodness. I'm ready for one. That last one was rough. So, what are we going to discuss over here? I guess the first thing we'll talk about is we're not going to rehash this galvanometer up here. You've had enough of that. But there's your galvanometer again from the front view. But I'm just going to go over here so you can see it. There's your housing that holds it in place. There's your aluminum galvanometer. Here's your blue wire. And here actually is the string. It's tied to a stud. But like I said, we're not going to discuss the string on this particular classroom slide. But since we talked about it in some of the other slides, I thought as long as we had a front view up here, we just have a quick look at it so you can see it from a different perspective. And there's even the adjustment screw there. It's visible. And over here, I don't know where that housing goes. I think the housing doesn't go all the way over the top. Over on this side, I think they've got some metal attached to it, and I can't recall. I think it goes up here and attaches to this top metal plate here, and it moves. And I think there are gears down here that are attached to it. But that's another. Oh, there's a string right there. See the string? Yay! All right, that's enough of that. Let's move on to something else. I want to get past this one. I've still got a few more slides to look at, and they're probably going to be rough. So, what's this all about here? Well, we talked about the self-timer, and it just had a couple of screws holding it in. And there it is. You can see it's brass colored. And right here is where you put your little lever, or you attach it. Get rid of that again. So what did I want to show you down here? What did I want to teach you? This right here is what I wanted to teach you. Here and here. A simple thing. Details. Devil's in the details. In another video, I might just say, put it on and move along. Or he might have an overhead camera, and you'll see him put it on, and they won't. When you try to do it, you'll run into all kinds of problems, let's say. So I'm going to get rid of that. When you bolt back on your self-timer, it's going to look like this. And when you decide to put your lever back on, it's also going to look like that. The problem is the lever has a stud on it, and the stud goes right in here in this gap. In other words, this right here goes up counterclockwise. This one here stays stationary. And the two, you can't get your stud in there from your arm or your lever that you're pressing on. In other words, you've put your lever on here and you're pressing down, but you can't get, it needs to be between those two. And you thought, well, now what do I do? Well, what you do is you move this up. You stick a knife blade in there. There's not much room in there, and they're really tight together. You push this up to about, excuse me, voice is given out, to about 12 o'clock. Then as you do, when you release it, it'll start winding right back down. And you don't want that. So you get this lever here, and you push it this direction, and it will stop your timer. So I'm going to go over that again. These two need to be separated. So you stick a knife blade in there, or whatever you got that's sharp, and you push this lever up, rotate it up to about 12 o'clock, and then release it. And then immediately push this to the left to stop your timer. When you do that, it'll leave you a gap in here that's big enough so when you put your lever on, it will fit in there. And then after your lever is on there and you've tightened it down, then you can get this and you can push it back to the right and let it wind down. That's pretty much it. By the way, in case you've lost it, there's a small washer that goes here in the bottom before you put the lever on. And I've lost a lot of them. And just so you know, if you're putting your lever back on the camera and you don't have your washer down here, it's not going to work. So if you've lost it, find it and put it in there. It's a pretty thick washer. It's like 1/4 of an inch thick, and it's very small. It's a spacer more than a washer, and your lever rides on top of it. So be sure and stick that spacer in there. Then, like I said, push this up. It takes a lot of pressure. It's hard and it's tricky. A lot of times I'll be pushing one up and it'll get away from me, and then it'll time down. I wait, and then once it's down, I repeat the process until I can get it up here. You can push it past. You can push it all the way to like 3 o'clock. But when you release it, it'll immediately start trying to time down again. And you've got to get this lever here and immediately push it to the left and stop your timer. Because if you don't stop your timer, by the time you get your lever on here, it'll already closed. It happens real fast. So that's it. That's what I wanted to show you on this side, to be sure. And when you put your lever on, to get these two here separated enough to you can get the tab in there. A small thing, but it'll drive you crazy. Okay, let's see what else we got here. If there's anything else that I can teach you while I'm here. The string assembly that I need to teach you and make a video class on is underneath this plate here. There, and there, and there. You've got strings attached to your speeds and your ring here inside underneath that plate, and you've got strings attached to the tab that your lens. When you put your lens on, it has a tab and it engages two, and I don't see them. Where are they at? Maybe it's just the angle. Normally it's right, I think it's right here. Your lens engages a tab right here, and that tab has a string attached to it also. So you've got two strings. You've got a string on your speeds and a string on your f-stops, and they go up here to the galvanometer. And this cover here has to come off to access them. And it's very dangerous, very complicated, in the sense that if you get it apart, you don't know what you're doing. You'll probably never get it back together right. I did a video on it. It's not thorough. It's not complete. I need to do a course to really do it right. But at least it will get you in the ballpark so you kind of know what you're doing. Get rid of all those again. Remember, two strings, one going to the speeds, one going to the f-stops. When f-stops are connected to your lens, and they both go up here to the galvanometer. They wrap around wheels, and then they go through a set of gears here. And the gears are set into ratios, which I don't even know what that means. But what it means is that the different gears are have different sets of a number of teeth on them. And I guess you would say in this sense that it gears down the movement of the galvanometer, because it doesn't move that much left or right. In fact, if I remember right, and I think I almost am here, this right here, that's the canister, that's the galvanometer, and that is just an indentation there. And then right over here is your housing. And when you turn your speeds all the way from 1,000 to, say, 1 second, or your f-stops all the way to f16 to f.28 or whatever you got, this galvanometer only moves that distance right there. I know because I've done it, and it's one thing I look at. In other words, when a camera comes in, I look at the galvanometer to see if it's moving, and it moves about that far. It doesn't move much. It couldn't. Looking from the top view down, if this was a galvanometer and this is your needle only needs to move this far. So if it only needs to move that far, the galvanometer itself can't move very far. So basically all these strings of movement up here are geared down, so the canister or the galvanometer does not move much. The people that designed it, they must be insane. And I'm just rambling here. Okay, let's move on to the next slide and see what's going on. All right, only 3 slides left. This OM-1's eating my lunch. I didn't think that it would be this hard. There's so much to show and explain, and it's hard to explain. I keep approaching the problems from different angles because I want, when you see it, to understand and to leave. And so when you get inside your own camera, I don't want to be any question about how things work and what they're doing. So I quite often repeat myself. Maybe I'm just getting senile. Possible. So we're looking at the front of the OM-1 here, and you can see the shutter on this particular one is in good shape. It's not discolored or damaged, and it's good. So what can I show you from this? Not much. When I took these images, I wasn't thinking of this class, so sometimes I didn't take it really at a good angle or at a good distance. But maybe I can teach you a little bit of something here. Zoom in here, and nothing you can do about it, but something I wanted to complain about. All the cameras, the Minoltas, the Nikons, if they have ribbons, some of them don't. They have vertical shutters. They don't have horizontal shutters. But the ones that do have horizontal shutters, they use a ribbon that goes across. In other words, they've got a ribbon that goes completely across from side to side. But Olympus, in its infinite wisdom, used a cord, of all things, top and bottom. And they really look crappy. I guess I'm just complaining. Olympus. That's such a weird camera. Again, over here, they used a cord. They did not use a ribbon. People love the Olympus. Like I said, I've owned one. They're take great pictures. Shutter speeds are extremely accurate, but when they were designing it, it was like they said, well, let's see how cheap we can make this. How can we make this where it has no electronics, it's all mechanical, and like up at the top where they put the, that spacer underneath the galvanometer to complete the circuit rather than using a wire. Anyway, I am rambling here. You stop. Here's your release for when you rewind your film. Again, Olympus put it up here at the top. I don't have the proper view here to show you how it works. Just mentioning it here. And I can't think of anything to show you there. There's nothing to show over on that side. Here's the timer. A lot of the SLRs put their timer in the bottom. Some of them put it up here in the top. And the rest put it down here in the bottom. A timer like this is only good for 60 down to 1 second. I'll get it here eventually. Rest of the speeds on something like a Minolta are from 60 to 1000 are controlled by cams. Olympus put the whole thing right down here. I don't know how, but it works good. Get rid of those yellow. And what can I show you down here? Not much. Maybe at a different angle I could explain it. I guess I can, for somebody that works on this camera, I can show you one little thing, and it's very tiny. If you look right there, you'll see a wire. Get rid of it again. You see that wire that goes to the spring right here? Well, many times when you're working on this camera and you've got the mirror cage out, your finger or a piece of cloth or a tool will catch right here on the tip of that spring, and this bracket that holds it only comes up to this level. And what will happen is you'll go over the top, and this spring will not be tensioned anymore. In other words, it's not holding its parts over here against the cam. This is your cam stack here. And camera won't work. I don't know how many times I've caught that. I'm going to say it's less than 100. But always, before I put the mirror cage in, this is just a good rule, check to make sure that the spring is behind there. Make sure that it hasn't come out and is just free floating over here or something. Make sure it's back there. In fact, sometimes what I'll do is I'll get a little contact cement and put it right here on this side and this side to make sure that that spring can't work its way over the top here and come out. Cameras are weird that way. It's just things that happen over and over and over, and that's one of the things that happens on these cameras. Okay, what else? I can show you in another view, but this gear here that I'm drawing here engages the speed ring when you set it here in the front of the camera, like so. Engages that gear like that. And whenever it is engaged, it's going to be hard to see from this position. I've got another picture that I can probably see it better. But you need to set that speed ring at 1000, and you need to put some red paint on the gears that engage the speed ring. I can't tell you much more than that, but if you're determined to go on the camera yourself and you really don't know what you're doing, in other words, if you take the camera off and it's an anything but 1000, and if you don't put some red paint on here, then when you put it back on, this gear could be in any position, left or right. Look at all these teeth here. How many teeth are on there? 50? And you won't know, and you will, when you put your mirror cage, the front on, back on, it will not engage the right gear. Only one, it has to be on one gear only. It can't be a two teeth to the right or two teeth to the left. It's got to be on the right one, period. And it's got to be set to a certain speed. You can choose whatever you want, but I choose 1000. I set the camera for 1000 when I paint the tooth that it's on at 1000. And then I go ahead and pull the mirror cage out, and I do whatever I'm going to do as far as repair work. And then when I put the mirror cage back in from the front, I make sure these teeth here will just move around. You can just push them with your probe. And I make sure the red one is dead center, and I make sure the camera is set exactly at 1000 so they match up and the timing is perfect again. And it's something like that an amateur would have no idea. It won't help you repair the camera, and it's not everything, but it's a big part of, if you've got that, you've got one half of what you need to know to get in this camera. There's more, but that's a good start. Is it make sure that this gear here, that you paint the tooth that is engaged to 1000. For what it's worth, you know, if you don't work on this camera, you won't even understand what I'm talking about. But it's just something to watch for if you're on your own. Okay, let's go ahead and move on to the next slide. Okay, we're at our next slide. Same mirror cage out from the front, but from the top instead of from the front. So, where should we start? Well, naturally, we should start on that gear down there I was just warning you about. We've got a better view of it here, so I'll go ahead and show it to you. Moving in, right here. If you look right here, it doesn't look red, but that's my paint on there that I marked it with. So even I do it, and there's no point to remove the red paint, so I just leave it on there in case I need to go back in the camera. But you see it's moved. It was over here. When I put the mirror cage back in, I will move it back over to this position, and I will set the speed control on the mirror cage at 1000 to match them up, to get it all back together. And right over here, we've got a nice view of this spring I was telling you about right here. Much better, actually. You can see the tip of it right here, this wire or spring. It gets caught on your fingers and tools, and it comes off this real easy. And then it will, when you look down, it'll just be sitting in here floating. And the camera timer, of course, won't work. It's got to be put back in here. And that's why I said I sometimes put contact cement here and here to make sure I don't accidentally pull it out. It's just in a bad place here to where it'll catch on your finger, your fingernail or something, and it doesn't take much pressure to pull it out of its notch. The timer, we were talking about the self-timer on the first slide. This right here is your timer for slow speeds. And right here, what I'm circling is the gears, the pivot points that have to be oiled. When I pull the mirror cage out, I have to put oil in these places right here. And then you can remove this whole thing and pull it out. But when you do, it creates other problems, basically timing problems. So I normally don't. I normally use I have an oiler, which is kind of like a syringe. You can buy them. They're not pointed. They're blunt pointed. So I may put a little oil up here, and then I insert my oiler underneath the gear down here. Same way on this side. Here's the gear, and I would put my oiler underneath it to reach the pivot point. And then up here, this is not a gear, it's just a lever. But again, put the oiler underneath it. Once I had oiled all these, I would get my air gun and blow air in here and blow all the excess oil away. And that would take care of if a customer comes in and he says, well, my 1 second is not even working and the rest of my slow speeds are way too slow, it's because this timer here needs oil. It's it's kind of separate in the sense that in fact, it probably, I don't recall, it's been a while, but possibly this screw here and maybe this screw. I'd have to look in one, but it will lift out, this timer will lift out. And the high-speed cams are down here that control the speeds from 60 to 1000. This timer right here, of all the timers on all the mechanical cameras that I've worked on, this is the most accurate. It's been 45 years, but still, this timer on the OM-1, when I put it on my tester, sometimes will not be close, but it'll hit on the mark. Like if I set I'm testing 1,000th of a second, these OM-1s I've seen again and again, they'll hit dead on 1,000th of a second, just like it had come out of the factory. Same way with 1 second. If I dial it in for 1 second, it'll come in exactly at 1 second. Or say a 30th of a second. It'll come in exactly at a 30th of a second. This, I don't know how they did it. I don't know what is special about this design. This mechanical timer on the Olympus is better than the Nikons, better than the Canons, better than the Minoltas. This timer on the OM-1 is just fantastic. And that's the only reason I don't just totally throw up my hands and stop working on Olympus, is because this one thing, this timer, extremely accurate shutter speeds after all these years. We're talking, I don't know how long it is since 75 to now, but for all that time, and yet they're still hitting dead on. Sometimes I have to adjust the curtain times a little bit, but other than that, these cameras have fantastic shutter speeds. And as far as the meter, I can't really say on the meter as far as how accurate it is. I doubt if it's as accurate as some of the other cameras. It's the shutter speeds that's outstanding on the OM-1. And I need to stop and move on. Okay, let's go on to the next slide. Okay, last slide. Getting late here. I repair during the day and make these videos usually in the evenings or at night, as I've explained in other videos. So sometimes when I'm getting toward the end of a video, it's getting late, and then I get tired and I start making mistakes talking and stumbling and rambling like I'm doing now. I've got 3 things down here to teach you. I could teach you a lot more than that, but 3. If you look right here, you'll see one of the rollers that we discussed. And if you look right here, you'll see those hated cords that I do not like. And then there's another roller back here. And on the very end of it, all SLRs have this, is an adjustment. And here's one right here. Circular. Right here there's a wire that presses against this disc, this metal disc. Over here there's one too, although I can't tell right offhand because I'm blocking my vision here. I don't know if it's, I think maybe that's it right there. And right there, of course, you've got your disc here and here. These are the curtain times. In other words, the opening and closing curtain on SLRs, most people think that they're connected, but they're not. They're both separate, and they have to be. So let's say the opening curtain, which is the one down here, opens first. How fast does it go across the film plane? Well, normally about 12 ms, or 12 milliseconds. It will start, go across, and it's over there. It's ready to go at 12. Well, then the back, the film, I'm back here showing you, the light is hitting the film when this opening curtain opens. So then the camera is timing, and let's say it's timing at 30th of a second. After a 30th of a second, the closing curtain has to come across. It also has to come across at 12 milliseconds. You say, well, why? Because if it doesn't, then the curtains start, the gap starts getting wider or narrower as it goes across if you're using speeds over a 30th of a second. At a 30th of a second, when the opening curtain gets to this point, the closing curtain releases and closes. And so you get your 30th of a second, and it's open, but from side to side, there for an instant. But let's say you're at a 2/50th of a second. At a 2/50th of a second, when the opening curtain, say, gets halfway right here, the closing curtain has to release over here. So the opening curtain, which is right here, is not finished yet. It has not gone to this side over here. But to get your 2/50th of a second, the closing curtain has to release. And what happens is, I don't know how to explain it, but the best way to visualize is like a Xerox machine. You've seen a Xerox machine where I don't know if they still have them, a lit bar goes across the document. Film cameras do much the same thing. They have a bar of light anything that's over a 30th of a second, a bar of light that exposes the film. You can't just expose all the film and then close it instantly. The older iris shutters could. Iris shutters, I don't know what they're called. Is that the way they're called? The round ones that had the blades inside. The blades could open and then close, and they could do that. But when you're talking about an SLR with a horizontal shutter, it uses a system of two curtains, and at anything below a 30th slower, yes, the whole thing will show, and then one side will close. But anything over a 30th, then you get in a situation where the two curtains are actually moving across at the same time, but at different widths. Like, let's say, I'm just off the top of my head, this is 250. And then if you start shooting past 250, then, one stop, then it gets narrower. And then what's next? 500, it gets narrower. And then you start shooting at 1,000, it can get really narrow. So you just got this one bar exposing your film as it goes across. Probably be best to do a search on Google or maybe one of these AI sites, and they'll explain it a lot better. I'm not here to explain how the SLR shutter works. Maybe if you're a total beginner and don't understand, this will at least tweak your interest so you can learn. But why all this matters? Why all of this matters? It matters because those curtains here, opening and closing curtain, right up here, have to be going across at the very same speed to get your higher speeds. You can't have one curtain if it, let's say that you're at 2/50th of a second, and this is not accurate, but if it starts out and this right here is your opening curtain here, and this is your closing curtain over here, and let's say the space that it's exposing the film is that big, if this closing curtain is going faster and faster, well, then it's catching up with your opening curtain. And did I get that right? If the opening curtain is, let's say it's at 12 milliseconds like it should be, but let's say your closing curtain is at 10 milliseconds. Well, then it's faster and it's catching up. And so as it goes across, their slit is getting narrower and narrower and narrower. And so at the end, what's happening is that if this were the window where the film was showing, what'll happen is this will be properly exposed here, but this right here will be underexposed, and this will be more underexposed, and this will be more underexposed, and over here it just might be a gray. So when you get your picture back, this side over here will be properly exposed, but over here it'll be dark. And I get customers bringing me film occasionally, a camera, and they'll say, well, one side of the picture is dark. Well, when they tell me that, I know immediately that these curtains are not going across at the same speed, and that the gap between them, the bar, like on the Xerox machine, is either getting narrower or it's getting wider. Because if this closing curtain is slow, then the opening curtain is going to go across at just 12 milliseconds, and the let's say this from over here is like 14 milliseconds, and it's slow. Then what happens is the gap is instead of getting narrower and narrower, is getting wider and wider as it goes across. So then you would have one side that is maybe overexposed, and this one right here, it might be underexposed. So the reverse could happen. But I'm sure there's articles out there that were written that could explain it a lot better. But hopefully you get the idea on why it's important to have these curtains going across at the same speed. And they will change over the years. They will drift because they're mechanical, and the oil on the shafts will dry out. And these will drift. Sometimes they'll get actually faster. Sometimes they'll get slower. And I have to set them on all cameras that have horizontal shutters. It's not a problem really on vertical shutters, just the horizontal ones. So, what else do we need to look at here on the bottom? I don't know. Let's look. Okay, I'm back. And what'll we discuss now? We talked about the curtain times there. Get rid of that. And that. So now let's talk about this right here. This is a big headache for camera repairmen and customers. Bad design again that Olympus made. This is not, I didn't research this, so this is not going to be thorough. I can't give you an exact explanation of what goes on here. I know that this right here is your charging lever, and that I know that this over here needs to be charged in the camera. In other words, when you're advancing your advance lever, what you're doing is you're turning this gear over here, and you're charging your shutter mechanism here. And the problem is this right here, which is, I don't know what you'd call that. Can't think of the exact word, but it's transferring energy from this gear to this gear. That's the main point. It just was a bad design, that's all. They probably did it this way to save money, or maybe save space, or maybe it was easier to manufacture this way. But anyway, why is that, you say? Well, this gear here, this tip, engages right here in this indentation here on this. This is a gear. I guess you'd call it a gear. I don't think of it as a gear, but that's what it is. As the camera advances, this gear goes this way. And as it does, this side goes down. And as it does, this one charges this way. Maybe that was the reason they did it, is because they needed this to go counterclockwise. And this particular, I don't know why they did it that way. And I'm sitting here looking at it, and you're going, get on with it. Okay. Like I said, I hadn't thought this through. Underneath here is a spring. This is what you need to know. And the spring is very weak. It's like the size of a hair on your head. I've never seen such a weak spring in all the cameras. And so what happens is, and I'm going to undo this, is that after this gear here finishes and gets in this position again, where this is at like 5 o'clock, this over here is charged and it's done. It's supposed to release this gear, and this gear is supposed to go counterclockwise and go back to the starting position. Starting position in the sense that this notch here is facing this way at about 9 o'clock, and it doesn't. That spring underneath I was telling you about is so weak that if even, this is going to sound weird, but if you get 1 grain of sand, we're talking, if you go to the beach, 1 grain of sand is all it takes. And this gear here will not spring back. Get rid of that again. See this right here? That needs to be right there to begin the cycle. This needs to be right here. This right here is not a problem. You're moving it with your thumb on the advance lever. You can put some torque in it. If there's a piece of sand in here, it'll just be crushed. And normally a piece of sand on this side will not stop it from moving either, because it has a lot of torque. But this center gear has no torque whatsoever. It's really weak, and this little spring here inside is really weak, and 1 grain of sand is all it takes. One, see there? I know because I've cleaned them out before. They came into the shop, and instead of being here, it was locked up here, someplace. I knew immediately that there was something blocking it. And so I would take out the center screw here, clean it with a little bit of naphtha, get an air gun. Inside I'd find maybe some dirt, a few grains of sand, something like that, that would keep the spring from pushing it back where it needed to be. And then I'd put the spring back in it, and the spring was so weak that sometimes just handling it would bend it, in which case I'd just get rid of it and put one in from another camera. Basically, it's a spring-loaded gear, and it's got a stud in there. You got to get the spring in right. You got to go over the stud. You got to charge it, basically. And once it's charged, that should be right there. Of course, this right here will be here, and it will engage it, and it will go around and push it, and that'll go this way, and this will go this way, and the camera will be working again. And the customer will be happy, and I charge them all kinds of money, and I'm happy, and we all live happily ever after. Hopefully. Anyway, what else is there to say? There is to say that this is a terrible system, and Olympus should have never made it this way. That they've cost customers over the years hundreds and hundreds of dollars just because of this stupid little gear here and its stupid little spring that is so weak that just a few grains of sand will cause it to lock up. And I need to stop venting here and move along. So I will. Okay. Let's move on to something else. What are we going to talk about now? Well, we're going to talk about this right here. It's another Olympus screw-up, which they did. And let's see if we can get in closer. There we go. Okay. Where to start? It's a mess. Guess I'll get rid of this first. This is the battery compartment. Here's the clip that the battery presses against. And how could Olympus screw up a battery compartment? I don't know, but they did. The battery that goes in here would quite often leak acid. Most cameras do, but on the Olympus it was a real problem to fix. That battery acid would wick its way up to this solder joint right here, and then go to this brown wire here. And the brown wire would go this way, and the battery acid would just wick its way, and it would come through that hole and go up here, and then go up here, and it would wick its way all the way up the wire. And the wire is usually around, 6 inches long, maybe longer. And you'd have to replace the whole wire. For some reason on the Olympus, when the battery acid leaks into the compartment, it would destroy the whole wire. It was one of the few cameras that I saw this happen. Here's the wire here. Normally the wire would come up, go around the galvanometer, across the front over here to a circuit board. Where it was attached to the circuit board up here, the solder would be white and corroded. For some strange reason, when the battery leaked on the OM-1, the battery acid the wire all the way up to this circuit board, which is very strange. It was the only camera I ever knew that would do that. So, well, you'd say, well, no big deal. Yeah, it was. I would have to replace this entire wire. As you can see, it's glued throughout the camera. And I'd have to go find another wire that was in good shape, that was that long. And it couldn't be really, large or stiff. It had to be a wire that a camera might use, very small and but large enough to carry the current. And I'd have to glue the new wire all the way in here until I had a fresh copper right here. It'd take a while. And then we went into problem 2. This clip here had to come out to clean this solder off it. And to do that, I had to take the screw out, and the screw was plastic. Sometimes when you try to take it out, the head would break off. And then sometimes when you try to put it back in, if it wasn't broken, the head would break off. On a scale of 1 to 10, if you put more pressure than a 1, maybe a 2 you might get away with. I wouldn't try it. I would stay with a 1 and hope that it works. The head would break off. And where are you going to find another plastic screw that's the right shape, that has the right threads? You might go to another Olympus camera and find one. But not all Olympuses had a plastic screw here, only the early models. Later, what they did is they used a metal screw and they put an insulating collar or a tube in. So what you would do is you'd come over here and you'd push the tube in first, the insulated tube, so the screw would not make contact with the clip. And then you'd put the screw in afterwards. And it was metal, so you could tighten it down. But on the early Olympuses, they all had this plastic screw, and it would always break off. You had to be really careful. So, enough about the plastic screw. So we got a cable that goes all the way to the top. We got to replace a wire. We got a plastic screw which habitually keeps breaking off when you're removing it or putting it back. And you can't put a metal screw in there because it will make contact with this clip here. So you've got to find a collar to insulate it with, which again, you're only going to find one probably in another Olympus. And so good luck finding that. Good luck finding a plastic screw. Probably any that you do find are broken. So, after you get the clip here out, then you've got this mass of solder you need to remove from it. That is a problem. I'm going to draw a picture here of the clip. Let's say it goes up and then down. And this is your clip, and this is your solder here that is acid damaged. It will no longer, current will no longer go through it. And your wire will not solder to it because it's damaged. I don't know how things like that work, but I do know that solder that has been damaged by battery acid, that is useless. You can't solder to it, and it won't pass current. So you've got to get a Dremel tool, and you get your Dremel tool down here. Let's see, is that a Dremel tool? And you can put a wheel on it, like so. And then you remove all that bad solder. But you not only got to remove it, I'm going to draw another picture here, a close-up of that same clip. You've got to, it's kind of like a tooth cavity. You can't just remove the cavity and be done. You've got to remove that battery acid damaged solder, but then you also have to remove part of the clip right here behind it and get into good fresh metal. You can't just remove the solder and be done with it. It won't work. I've tried many, many times. Once you've got your clip, all your old solder removed, and you've got kind of a cavity here. You want to make sure it's not smooth, but it's rough inside. And then for some reason, normal solder, and I've tried different types of solder, will not stick to this clip. This clip right here. Normal solder, again, will not stick to it when you heat it up. And so you use what we call solder flux. You've got to have solder flux or your solder's not going to stick at all. So you put your solder flux in here, a lot of it. You stick the head of your wire in there. You heat it up, and then you pray to the camera gods. And sometimes you'll see the solder spread and stick to the metal on the clip, and you're good to go. But sometimes the solder will just pool on top, and then you know you're in trouble. If it doesn't fill the cavity and flow into it, then you're in trouble. If it just pools on top, it did not stick. And what'll happen is you can just push it off with your finger. It is not stuck on the metal. It's not making good contact. It's just laying on the surface. So I don't know how many of you out there do any soldering, but you'll know what I'm talking about. There are just some metals that for some reason solder does not stick to, and it's really hard. And this clip happens to be one of those metals that is really hard for solder to stick to. So remove all the solder and dig down into the metal. Apply solder flux. Use a really good hot iron. Put your new wire into it and then apply your solder. And if you get it hot, and with a little bit of luck, it will flow into that cavity, and you'll have a good solder joint. But there are sometimes I have to do 2 or 3 times. Between each time, I've got to clean this cavity again. You need bare metal. It needs to be rough. It needs to have flux, and you got to flow it into there and have that wire on it. And this is what I mean about Olympus. It's just causing all these little problems. Like over here, I was talking about that thin wire spring not having enough torque to return this. It's little things. If it was just one thing, I could forgive Olympus, but it's all these little things throughout the camera that they did, which made my life made a lot more work for me. So once you get your wire in here and you've got a good solder joint and you know it's going to make it's making good contact, then you've got to put your plastic screw back in. On a scale of 1 to 10, I would not go more than a 1. What I would do is put some contact cement around the plastic screw and screw it down to a 1 and leave it alone. You'll want to tighten it some more, but if that head pops off, you're going to be in trouble. You've not only got to find another plastic screw, but you've got to dig out the screw out of the threads. Or you can maybe find an Olympus that has what I was talking about before. It has the metal screw and has an insulated collar, which is what they used later on these OM-1s. But that's about it. What else? Is there anything else? This screw here, don't take it out. You don't want to remove this battery cover, this battery holder, because just trust me, it has to do with causing problems, because this battery cover goes into a shaft, and you don't want to mess with that anyway. So just again, leave this screw in. You can loosen it if it will help get your clip out. If the clip, if taking this screw out is not enough, it's the collar here is blocking it, then yeah, you can loosen this screw here, but don't take it out and then pull this battery compartment out of the camera, or you'll get more problems and things that I'll cover maybe someday in a camera course if I ever get enough Patreon supporters and make videos full time. I need to stop. It's getting late. It's about 10 o'clock. I've still got to do an outro and load this into my computer and get it ready for editing tomorrow. And so I guess that's it. Let's go into the outro. Okay, that's it. That's the OM-1 classroom video that someone requested, whose name I forgot. But only took a week to make, and take 2 days to edit, and then I can upload it, and then 3 people can watch it. What a life. Anyway, when Olympus made this camera back in '75, I'm sure they had no idea that it was going to be this popular, or people would be using it this long. So I'm try to respect that, and when one comes in, I do the best to repair them and keep my sanity. So I guess that's pretty much it. It's 10 o'clock here at night, and I'm tired. I'd make these in the evenings or nights, and I'm ready to call it a day. Thanks for dropping by. Hope you learned a little bit about the camera if you work on them, and I guess that's it. Later.